Hello everyone, my name is Anthony Fisher. I'm in instructional technology with Sharon Faith. What we are doing today is just a little demonstration of how to actually what a flipped classroom is. Now, what it is a lesson online that we could use as teachers, so you could teach a lesson as homework and do the activities in class to get more work done and keep the students more into the lessons and to be able to fully learn and understand everything. So today what we're doing is learning how to graph basic linear and polynomial functions with their base graphs and also with their graphs if they were to with alterations in them. So what we're going to be doing today is using GeoGebra, a Web 202 tool, to help give you a visual understanding of how the graph shifts depending on what kind of equation you put in. So today what we're going to do is start off with just a basic linear equation that almost everyone should know in algebra at this point, which is y equals x. Now this is just a real quick equation. I'll also change the dimensions of this, and I will make this a red color so you know what exactly the base graph is. Okay, so this is the base graph right here. This is y equals x, where the original equation is y equals mx plus b. Now what this is, m stands for the slope of the line, so in this equation right here is 1, since there's only the x, and the b is the constant, which is the y-intercept to have the graph shift up or down. Now there's no b in here, so the y-intercept is 0. So what I'm going to show you, I'll put in another graph. I'll change just the y-intercept at this point. So you could get y equals x plus 5. Now as you watch this, the graph will change. Now see, the second line that you have is still the same slope as your original y equals x, but this now has y equals x plus 5, so that means the y-intercept is 5. So you go up 1, 2, 3, 4, 5 to get that point, and you graph the same slope of a 1-to-1 graph of rise over run. Now I'll just show you a little bit more of alterations that could happen. You could also have y equals, let's say, 2x, just to see how the slope changes. So now what you see is the y-intercept is still at 0, but the slope has changed. Instead of going up 1 and over 1, it goes up 2 over 1. So the slope does change. There is a little bit of alteration. Now you could put both of these together by putting in y equals 3x minus 4. Okay, we press enter. Now you see this next line right here, D, as you see it's highlighted. It is now has a y-intercept of -4 because you see by the -4 right there. So you will go down 4 to get your y-intercept, and now this 3 right here is the slope now. So instead of going up 1 over 1 or up 2 over 1, what you'll do is you'll go up 1, 2, 3, and over 1 for the slope. Now there also could be fractions as you slope. So you could also enter y equals 1/2 x, which will change the slope to make the slope more horizontal right here. I'll delete these really quickly for you so you could just see the one that we're looking at right now. Now you see the slope is different. It's now up 1 over 2 slope, but the y-intercept still is the same. Okay, now let me just delete all of these. And now what we'll be doing is a basic function where it is the base of x squared. So y equals x squared. Now you see this is the base graph. This is an exponential function, but there's two sides to it, so it does not pass the horizontal line test, but it still is a function because it does pass the vertical line test. That there's no 2 points on the same for every x-axis. There's at least one y-axis. Alright, so I'll go into this, make the base graph red, just so you know how to base it off of. Alright, so now what we want to do here is show it's the same thing. You could go x squared, excuse me, y equals x squared, and you could do plus 2. So we'll see, we'll press enter and see how the graph changes. Now you could see, I'll move it a little bit so you could see up top that the vertex is different. You see how there was plus 2 right here, so we went up 2. Although the other parts of the graph did not change. The only thing that changed was the vertex. So not a big change. Now we could also do now this. You go y equals, you put parentheses x minus 2 squared. Now you see the function changed right away. Now it's the same exact thing as I put in as the parentheses x minus 2 squared. The only difference is this is actually all foiled out. These two are the same exact, this function and this function is the same exact thing. This one is just factored out, so you don't have the parentheses. It's still the same thing though. But as you see, from this function, it's x minus 2. You would think it would go over to x minus 2. When a function is inside the parentheses, it's the opposite. So say it's a minus 2, you go over to the right 2. If you were to go y equals parentheses x plus 2 squared, as you can see, this new function right here has went over to the left 2 because it was x plus 2 in the parentheses. Now I'll delete these graphs and put it all together at once. I'll keep the base graph right here, and we'll do now y equals x minus 4 squared plus 5. Alright? And I'll rewrite this right here just so you could see a non-factored version, a non-foiled version without the x squared into it. So this was, as you can see, if you ever forget, you could go by the graph. So this is x minus 4. As you can see, the 4 is to the right. This vertex is over to the right 4, so it's a minus 4 squared. And you see how the vertex went up 5 on the y-axis, so you would put plus 5. And those are just a little bit of simple transformations between a basic linear y equals mx plus b and also a basic parabola of y equals x squared. And that was just a little bit of a demonstration of it. I hope you enjoyed it. Thank you.